we're back. I'm giving a few seconds for the people that have tabbed away to tab back on the right Twitch tab. Stop watching Ninja. um. Oh no, Surad, you triggered a blue screen, but blue screens are disabled during showtime. Sorry. I refund your points though. Don't worry. Scammed. No, I can refund those points. And okay, so error, panic, or unreachable. Let's find out. Let's find out. So, closing the yeah. Okay, error, panic, or unreachable. So, this is a presentation. This talk is about deciding which to use in different situations, and the idea is that you started programming in Zig. You now know what these things are. You've seen them, so you have a general idea what they are. I will also introduce them again, but the idea is that you kind of know what a panic is, you know what an error is. You also have seen unreachable in a bunch of places, but at one point, like you're writing your own library or even just a function inside your program, a like function like nested inside a little bit, so not top level in the main, and you wonder, oh, this weird condition, should this be an error? Should I panic? Should I write unreachable? And I think there are these are questions that everybody stumbles upon sooner or later. It happened to me for sure. So let me try to give you an overview of what these things are. As with my last talk and also on my talks in the near future, I'm not going to go too much into details on one specific topic. I just want to give you an overview and a general understanding, like guide you towards the right direction. But after that, it's your job to go read the documentation and learn more, or go on Discord, IRC, Reddit, and ask questions there if you are still uncertain. So, have you ever written a program that handled all errors correctly? I think I should really give chat a moment to answer. Like, raise your hand if you have. I don't think I have, honestly. I think I'm not joking. I think until today, I did a pretty good job, but I never really got to the point where you say I handled everything, and it's important. Proti says yes. Hello world. Well, we'll see. We'll see, my man. We'll see. But that's for the end of the presentation. So this is seriously interesting. If you if you program professionally, chances are that you never do that correctly. But it is important. We realize it every day. Software is broken all the time. And if you just saw the presentation from Felix, there are serious reasons for having your programs be stable and not explode when something bad happens. So that said, while we know what the reality is, for this presentation, let's just make a courteous assumption that yes, we do have the time of thinking about not just the happy path in our program, but also to handle all the weird things that can happen, all the weird situation states that the program can end up in. Well, that said, handling errors, to be fair, such an easy problem, right? I mean, this is going to be like a 20-30 minute talk. I'm sure we're going to cover everything from start to finish, right? No. No. It's not easy. Handling errors is complicated. As I said in the introduction, I am going to cover different means, but I won't go into the details. So, and also, if you've probably seen other talks about error handling. There is so much depth in there. Whether you're building a program, whether you're building a library, depending on who your end user is, so it's a serious problem. Anyway, what do we have in Zig, or more precisely, what am I going to cover today? Well, today I'm going to cover briefly Zig errors, panic, unreachable. These are the ones in the title, but it's not just those. There's also compile error. There's also errors as values, and there's probably more. There's also other things that maybe should be in this presentation, maybe should not. I wasn't sure. So this is what I'm going to cover today. But an exemption could be optionals. Optionals are in a sense connected to handling errors, but also they are somewhat, I think, easier to use than the other things that I'm gonna mention today. So let's get started. Compile error. What's compile error? Compile error is a programming error that you can discover at comp time. Compile error, the way the statement, the built-in works, it relies on Zig's lazy evaluation. So generally speaking, you put a compile error inside an if statement. So your if statement has a condition that can be resolved at comp time, and that's a failure condition. So if the failure condition happens, the if gets simplified and just the compile error remains, and that's gonna cause the compilation to fail. Normally, you want to compile error takes an argument and a string argument, and you want to put in there a useful error message so that the user, which in that case is a programmer, can fix their code. As I said, it's a programming error, so who is going to read those errors is another programmer, not an end user. Let me give you an example. Let's say that you have this function called insensitive equal, like it's a case insensitive equal, and for some reason you decide that one of the two strings should always be uppercase because it simplifies the comparison algorithm. It actually does. Not sure if it's worth making a function for it for normal cases, but your function then relies on the first argument being compile time known and written uppercase. But some people might misuse your function, right? So how do you do it? How do you enforce that constraint? Well, inside the function, you can write in line 4, which is gonna check that every single letter is uppercase, and if not, or actually, let me flip it around. If it finds a lowercase letter, it prints, it just compile errors with a message. So if you write this in your code, and somebody writes a main function, so writes a program where they use your insensitive equal function, but they misuse it, right? The first argument should be all uppercase. When they try to compile, they get a compile error, and the compile error tells them that upper must be all uppercase. And you even get a nice error trace that even points to where they made the mistake, which in this case it's line 24, but because that's from my real example, it would be line 1 if I actually ran the program from the other slide. Next, panic. So let me see if there's anything else that I should conclude with. No, not really. I mean, compile errors are so nice. I guess in C++, people use asserts for this and then get all surprised when people make up like a release and with optimizations and assets disappear and oops, now everything is broken. In Zig it doesn't happen because there's compile errors are precisely checks for the compile step. Panic. What's panic? Panic is an unrecoverable error condition that you discover at runtime. You should not have panics inside your libraries, generally speaking. And in practice, most of the time, they are the equivalent of to-do error handling. So is what people tend to abuse a little bit. How do they look in practice? Let's say that you have this function that should do something with a line read from standard input, something like this, I don't know. And if the buffer length is 0, so if it didn't capture anything, then whatever else you're trying to do doesn't make sense. So you check for the error condition, then boom, panic error. And this is what you will find out in the wild, probably, in all languages, not just Zig. Panic error to do error handling, right? That's the reality. But there are sometimes conditions that are really unrecoverable, especially when your application, when you are at the top level, right? You are inside your main. In there, sometimes there are errors that you don't have a good strategy to recover from. So sometimes, generally, the right choice is to just just crash. And when it comes to systems programming, maybe that's not often the case, but I made in the newsletter, I put this as a joke. But when you're writing like distributed services, it's a reasonable choice sometimes to just crash and let whatever else is outside, like the Kubernetes or whatever is in fashion now, have that thing spin up another process. Because sometimes you encounter error conditions where it's completely out of scope from your application to try to address them. So for example, let me give you one example about web stuff. You're writing a web service and you cannot connect to the database. What do? There's nothing you can do really, right? It's not your program's role to, I don't know, try to restart the database. Normally, that's not how you would want to do things. So at that point, you just panic. That's reasonable. Let's talk about now Zig errors. Zig errors are recoverable error conditions that you discover at runtime. They are error codes only, not messages. So they are basically, think of them as enums. You can access the error name, so you don't worry, you don't have to like have learn which number corresponds to which error, because they're defined inside a header file somewhere as macros. But they don't carry payload. So if an error of one type happens, there are no other context information that error codes will that Zig errors will carry with them. They are implemented as a union. They are, if you look at the documentation, you can find information about the error union, and they usually errors attach themselves to the return value of a function. So they don't behave like exceptions. They are normal values, and Zig has a built-in syntax to have you create a error union with your expected return value. And then we'll see the code example later. So there are a lot of language tools to manage Zig errors, like a lot. I'm not going to cover them today. You can unpack errors in many different ways. There are many different keywords that help you manage them. I'm going to just show you a couple. And again, the point is not to give you a full introduction to Zig errors. I think Zig errors by themselves would probably deserve a couple of talks, one for a general introduction, one for maybe advanced patterns and funny tricks that you can use. So I'm not even going to attempt that. But just to show you an example, you have, I don't know, this function that it's parsing from a buffer a number. So we have this buffer is basically a string. So we have this string, we try to parse a number into a usize number base 10, and we return the next number. Not a particularly great function, but just as an example. As you can see here, parsing the number can fail. Makes total sense, right? We don't know what string is in here. And this is why we have the try keyword. The try keyword will take the result, the value that resulted from calling this function. Try expects the return value to be a error union. And if it finds that we are in the case where it's an error and it's not the correct return value, it will automatically return that error. The exclamation point before the usize here, this is the return value of our function, right? The exclamation point says, well, in success case, we want to return a usize, but in a failure case, we're going to return an error. So that's the exclamation point. Again, there's a lot more to say about this exclamation point and try and everything else, but I'm not going to cover this today. But you can see how generally speaking the flow would be, right? If you try to call this and there's like 100 in the buffer, then it will succeed and it will return 101. But if you call it and you pass it banana, and what will happen is that if your main also calls that function with try and also the main has exclamation point void as return value, Zig will print the error, invalid character, because it finds a B, not a good number, not a good digit. And then it will show you the error the error trace. So it will show you that the errors came from here. There's also the stuff that I omitted to have safe space in the slide, and it will bubble up to where it actually we had a try. So from hello.zig, this is the code from that I ran this example from. So it will show you also what the error did. Next, I said that these are recoverable errors, right? So recoverable errors means that you can also do something with them. You're not supposed to just throw them up with try all the time. Sometimes you get to a point where you can actually do something about them. And another language feature that you have is, for example, catch, which is kind of like try in the sense that try does something when you are in an error case. Catch, likewise, captures the error if the return value from calling this function ends up being the error case of the union. And then we switch over this error, and we can switch over it, and we have two errors that are possible from parseInt. Again, I didn't show this feature, but also you know which errors come from functions. This is something that the Zig compiler will tell you. Except in particular cases, normally you will know precisely what all the possible failures are. And in the case of parseInt, these are actually the only two possible failures. It either overflows because it turns out that this number is not, like, usize is not big enough to hold that number, or returns invalid character, which was the case from banana before. And here, if you capture them, then you can think of what to do in that regard, what your recovery strategy is. So with panic, you cannot really do that. So I made a distinction here between recoverable errors versus unrecoverable errors. Which is which? The answer is you decide. There is no fixed rule that says this is a recoverable error, this is an unrecoverable error. It's your choice to decide. Well, if you are writing the application, if you are the final programmer, you know what your domain is, you know in which context your application will be run, and then you know what your application is supposed to manage and what the application is not responsible for. So, for example, if the database is dead and you cannot connect to it, maybe you can retry a couple of times, but after a while, there's nothing else you can do. Maybe you can retry indefinitely, but you cannot do much more than that. While for other error conditions, these are errors, but in a sense, they are business as usual, right? They are error conditions, but they're expected. So for example, if you're writing a command line interface, you should expect your users to write commands that don't exist, have typos, make a mess. These are errors. But they, as I said, they are very much errors that are expected, and it's no discussion that your applications should handle them. So you should not panic if your user types a command that doesn't exist. One last thing that I would say in that regard is that there's also a difference if you are, as I was saying earlier, if you are the top level programmer, if you're the final programmer, and then after you, there's going to be just users. That's one thing. But if you are a library author, if your application ends up being used by other programs, by other programmers, then it's a bit different, right? If you're writing a Zig library, you most probably do not want to panic. Although that said, when you not panicking means that you need to, your API needs to account for all these error conditions. And I can imagine maybe some situations where your library, where you're writing a library where you don't expect the other programmer to really be able to handle everything. I don't have a good example right off the top of my head, but the point is, these are the decisions that you have to make when you're writing code. And generally speaking, in libraries, you don't want to panic. You want to give an opportunity to your caller to handle any possible error. Now, let's go talk about unreachable. Unreachable is a bit peculiar, and it's used to express when a situation is impossible, when you cannot express that through other means. So as an example, we use types a lot to constrain the space of possible states as to avoid invalid states. That's probably the best way of doing that. Like the best way of avoiding invalid state is not to have it representable at all in the system. So an example is that if you have a function that doesn't work with negative numbers, you have it accept a unsigned number, and that's a good way of avoiding it. But you cannot do that always all the time. So this is where unreachable comes into help with that. Now, unreachable means that you are providing from the outside a guarantee to the compiler and also to other people that are reading the code, actually. So other people that will write code, use your library, etc. When you are debugging, when you are doing a debug build or a release safe build, undefined behavior will be safety checked. So if that situation that you just said it's impossible actually happens, Zig will panic. But if you are compiling in release safe mode, then you end up having undefined behavior, which is a problem. It's a very sharp tool. So unreachable is a very sharp tool. You should use it with care. And let me show you a practical example of where you might want to use it. So this is similar to the previous example where we were parsing a number, right? But this time there's a small difference. Now buffer, it's not a slice anymore. So we know it's an array now. It's an array with with a length of 3. So we try to parse 3 digits inside a U32 base 10. And we know that it's impossible for 3 digits base 10 to overflow a U32 number. So we can say, so while we are handling all the errors, this overflow error, we know it cannot happen. So if we didn't have unreachable in another language, maybe here we would say, we would leave a comment, we would do nothing, and maybe we would leave a comment like, this should not happen. Or maybe we leave a panic or something. We do something that it kind of feels weird, right? Because you know this cannot happen. But in Zig, you can have unreachable. Now, this unreachable, it's nice because first of all, it will be checked in debug and release builds. So if you have a test and which is a reasonable expectation, you should test your code, right? But if you have a test, how can I say? If somebody changes this number and this ends up happening, so maybe they change this 3 to 300 or 3000, I don't know, and they trigger this case, the test will fail, and you will see that happen in your tests. But otherwise, as long as this stays like this will allow the compiler to optimize this code in a way that it would not be otherwise be possible, because the compiler doesn't do this kind of reasoning. Actually, I don't know for sure, to be honest, but most probably doesn't do this kind of reasoning. And in any case, this is just an example. There are always cases where you know something that the compiler doesn't know or cannot even know. So this is unreachable. Now, why do you want unreachable? I mentioned like that the compiler can optimize stuff, but let me try to answer a few questions and dive into that a little bit more. Why is unreachable at all? And the answer is, I would say, mainly performance. The second reason is that, as I said, there are some situations where you know a situation is impossible, and maybe you have to make the type system match, and it's so annoying because there is no good answer, or like you don't have, it feels really bad. I don't know if it happened to somebody, or I think it happened to me multiple times in the past. So I would assume this is something that happens fairly frequently, but it really helps you work with the type system in a very nice way. Because unreachable is one of those types where Zig knows that if you end up in there, well, that you don't end up in there, actually. And so it won't annoy you with the type system. Is undefined behavior that bad? So what happens if you get it wrong? You should not get unreachable wrong. If you get it wrong, test your stuff. Please write a test for your unreachable stuff to ensure that it actually really is unreachable, so that your test can fail. But what happens if you end up with undefined behavior and runtime? Is it that bad? Yes, it's super bad. Undefined behavior means that people keep repeating anything can happen. The practical answer, I guess, is your stuff will break and misbehave in weird ways. And the reason for that is not necessarily because the computer is evil and it's punishing you for getting things wrong. maybe. But the other reason is that, well, Felix earlier mentioned games like TIS 100, TIS 100, and Shenzhen IO. Like, I remember playing Shenzhen IO, and I forgot to put a screenshot of that. But in Shenzhen IO, it's this game where you are basically an electronic engineer, an electric engineer, and you're building circuits and programming stuff, and you have to manage the budget of what you're building. So if you add more chips in your stuff, they're gonna be more expensive and you lose points. And also you have constraints in terms of space. And then after you build your stuff is supposed to respect a set of specifications. The game tests your circuits, so it has a testing routine where it tries to utilize it, and it has to perform as expected, right, to specification. I remember that there was one level where you had to build a controller, like a gamepad. And I remember trying to build a super cheap, crappy gamepad where if you press too many buttons at once, it would not work anymore. So you could press 1 or 2 buttons. I don't remember precisely the limit, but like it would work for simple cases. But the moment you tried to use it seriously, it would misbehave in weird ways. And why was that? Because I was trying to be cheap with the number of lines running through the thing, and I wanted to save a couple capacitors or something. So, again, the spec that I was given, so I ran the test, and I think I passed that level, and because the spec that I was given did not account for that possibility. So, I'm mentioning this because undefined behavior exists because your machine mimics the semantics that you are trying to give it to it. So when you're doing a sum, the machine is mimicking that sum through other things that happen in the circuits, and that means that the machine is not precisely doing what you're telling it all the time. Then undefined behavior basically means that according to the spec, you are trying to do something that you're not supposed to do, and so the machine will not only misbehave, but it will misbehave in weird ways, in ways that don't map correctly to any of the semantics. So this is the undefined part, or the maybe confusing part, the reason why people say the machine will be able to do anything. It won't really be able to do anything, but it will start misbehaving in ways that are dictated by reasons that don't map to the specification even remotely. So, long story short, undefined behavior is bad. So why do you want to have undefined behavior? Why is it like not avoiding undefined behavior in all possible cases? Well, if you are building, again, if you're doing a debug or a release safe build, you will not have undefined behavior. It will catch it. I think most cases. I think there is a plan for everything, but I think there are a few cases where you can trigger it anyway, like writing in the wrong memory. But anyway, these things are being addressed. But if you're building a release fast mode, all these safety checks will be removed. Everything will be simplified, and that is what has your application run much faster. It's a performance optimization, and the performance gains are good enough that it's worth having this stuff. So that said, another thing that maybe sometimes I've seen programmers get themselves lost a little bit into is, well, but I'm saying that this is unreachable, but what if something weird happens, and even though this is never gonna overflow, but somehow a bit gets flipped in RAM and another program messes up with the memory of my program, and we actually end up with an overflow. And if I leave unreachable, then my application will be broken. And the answer is no. These type of failure scenarios, you cannot account for them in programming. If your machine is broken, then nothing is gonna matter anymore. Or if something else incurred in undefined behavior, then everything else is invalidated. There's a interesting talk about this that unfortunately I could not find a link for, but if I do find a link, I'll add it to the video description on YouTube, which was about weird machines. And the idea was that once your machine enters undefined behavior town, then everything is possible, and there is really no way of going back from undefined behavior, at least through normal means, and with the architectures that we have today and in our homes. So, long story short, unreachable is, I mentioned unreachable because it's in the ballpark of errors, but it's for optimizations and it's not for errors. Use it with caution. The compiler, with unreachable specifically, the compiler will always have your back in debug and release safe builds. And when you have code that needs to go really, really fast, unreachable will be a very useful tool. But again, you have to get it right. If you don't get it right, then stuff like this happens. Honestly, I don't know if this is because of undefined behavior. I have no idea. It's just a funny screenshot. Yeah, there are consequences if you get it wrong. Okay, final topic, I believe, errors of values. This is in some ways a milder topic, I guess, but I think it's one of the most useful because here's the problem. Zig errors don't carry a payload, right? Exceptions in other languages do carry a payload. Zig doesn't, because Zig errors, you want them to be small, right? You want them to occupy, you don't want to have a big overhead for moving around those errors. You want them to be useful, to be better, I would say, than like error codes from C. But you would have a lot of overhead just to ferry around strings when maybe somebody doesn't need them. But sometimes you do need errors. You do need payloads like strings, something that gives you more context of what the hell is going on. So in that case, you should implement them yourself. And you can just do a tagged union, and you have your type, you make a tagged union with your error type, and the error type can be whatever you want, and you can tailor that to your application domain. If you want to have your own custom errors and you don't need any payload, consider using Zig errors. So I didn't show you how to make your own errors, but actually super simple. You just type error dot blah blah, and whatever you write, like you don't have to declare them beforehand. You just type error dot whatever it is, and Zig will do a lot of that work for you. So they are really, really nice to use. Let me give you an example then of using errors as values. So this is from my Redis client library. It's on GitHub, Christoph-it/zig-ok-redis. And there are the library basically is trying to give you a nice, easy to use interface and help you with a lot of stuff and give you flexibility. But at the same time, I wanted to make sure that the library did not have any foot gun in it. So there should be no gotchas, no behavior where, oh man, the library really screwed me in that situation. I didn't know this. This is something that you should not do with the library. I wanted to avoid all of that. So when you try to send a command, so get key, this is a Redis command. If you don't know much about Redis, it's a key value store. And you can send commands like set key, get key, and a bunch more. Here, I'm trying to get a key, and I'm also requesting that the result value is decoded into a I64. So I'm expecting this to return a number. There's a try keyword, because whenever you call, so I'm not showing you everything or how to instantiate it and everything else. I'm just showing you just the core part of the API that deals with errors. So the try keyword is here because there may be a lot of errors that can happen in here. You're trying to do network I/O, right? So there could be broken pipe. There could be a bunch of networking related errors. But on top of that, there can be other errors related to types, and there can be other errors related to Redis errors. So this command can return you a Redis error. Maybe you don't have permission to access the key. So here, the return value, the expected return value, I64, doesn't account for representing errors. So what I did in this case, using a bit of metaprogramming, is that when you encounter a Redis error, This will return you in the case, so like you get an error that says that you don't have permission. Here, this will return a Zig error called got error reply. It has a bit of a wonky name, but it's on purpose because it's not something you should abuse. So in this case, I will convey an error condition sent by the server through a Zig error. But at the same time, I also provided a generic type which takes in any type that you want. So it could take in I64, for example, or it could take in other types. And what this type does is basically create an error union. But this error union is specific to my domain, it's specific to Redis. So what it does is that here, I didn't do const reply equals, but imagine, because I didn't have much space, but imagine this is const reply equals, and then this command. When you then get the reply, you can switch over it, and it has 3 cases: nil, which is a special case in which Redis, it's null from Redis, whoops, it's null from Redis. There's the error case, and in my type, I'm not only having the error case just as a Zig error that doesn't have any payload. In this case here, I'm also carrying, I'm also deserializing from the connection. There's a short string that tells you a little bit more about the error message from Redis, and I'm giving it to you. And that's because I engineered this type. And then there's the OK case that returns your type, whatever it has to be. So in this case, I'm using both. I'm giving you an option. Do you want to inspect errors and like pay the price on your stack frame to store the error case and do something with it? Or are you fine with just the enum from Zig? You can choose. Either way, it's fine. Either way works. And I'm allowing you to use both. And I think it's very beautiful that you can bounce from one another. And the interesting thing is that here, if you try to handle all error cases with a switch case, right? So not just with try, but with a switch case, the switch case will tell you what are all the possible errors. And from this call, you will have to handle also got error reply and got nil reply, because I64 doesn't handle nils, null replies from Redis. And you will have to handle both. While here, if this try becomes a catch, you will have to handle potentially all the networking related errors like broken pipe. But here you will not have, again, I'm clicking, you will not have the error case or the nil case. Another thing that I did in my language here, if instead of I64 you have an optional, so question mark I64, an optional I64, the got nil reply error will disappear too. So it's nice. You can do this stuff, and I think it makes for beautiful APIs. To recap, Zig errors, they're very nice, but they don't have payloads. And it's actually nice that they don't have payloads. You don't want everything to be, every error, you don't want to pay a big price. You don't want your functions to like go at half the speed just because you implemented errors. They have very little overhead, and that's amazing. Panic, it's for runtime. Don't be lazy. Don't abuse Panic. If you're writing a library, please don't leave panics around. Unreachable, it's for performance, and it's checked for safe modes, which is nice. Write tests that ensure that your unreachable stuff is actually unreachable so that you can discover that. Compile error is super nice because it gives you compile time safety, and it makes for better APIs, because you can have an API that has a usage contract that is a bit more nuanced, but there is no runtime price for it, and there is no jankiness related to it, and that's amazing. Errors and values for when you need payloads, for when you want to do something more nuanced, something that applies nicely to your domain. And that's, I think, is pretty much for